So also each team must be monitored by an adult supervisor, and there is no discussion of problems until the contest ends among like non-team members. This includes posting the problems online. So here are some things that are allowed. So none of the problems will require a computational aid or a computer, but writing computer programs is allowed along with using books or other references. But the limit on this is that teams must fund these materials themselves without help from people not on their team. And also communicating with non-team members to get help during the contest is not allowed. So this is just some of the rules that I thought were important. For the full list of rules, that here is a link, and also the rules are subject to change at any time. Okay, so Purple Comet is a team competition. So we'll be going over who can be in a team. So teams can have 1 to 6 students, and there are 8 kinds of teams that can compete in Purple Comet. So first, teams either compete in the middle school or the high school competition. And for the middle school and high school competition, there are 4 types of teams each. So there are competitive teams, small, large, and mixed school teams, and non-competitive teams. Not anyone can be part of a non-competitive team, regardless of their age or grade. But members of a competitive middle school team, so these 3, must be at most 16. No, must have not turned 16 yet by the start of the competition and not have completed 8th grade yet. And similarly, members of competitive high school teams must not have graduated high school by the end of the competition and must be under 20 years old. So of the competitive teams, there are small, large, and mixed teams. Small and large teams, their members must all be from the same school, and that the number of students in the school determines whether the team is small or large. So a middle school is considered small if it has less than 400 students, and a high school is considered small if it has less than 1,200 students. Otherwise, a middle school or high school is large. And the type of a school, whether a school is small or large, determines whether its teams are small or large. Okay, and also there are mixed teams. So mixed teams are designed for like homeschooled students or students from different schools that want to take the competition together. But there still is a limit. Students on a mixed team must all live within 150 miles of each other. Also, an important thing to note is that although no student may participate on 2 middle school or 2 high school teams, a middle school student can still participate on 1 middle school and 1 high school team. Okay, I said before that teams must be supervised, so this is who can be a supervisor. So every team must be monitored by an adult supervisor that's at least 21 years old, and this supervisor is there to make sure that their team follows contest rules. So to become a supervisor, a person can register themselves and the teams that they'll be supervising on the contest website, and they can register anywhere starting from February 1st to the end of the competition each year. So this year the competition is taking place from April 22nd to May 1st, so there's still time to register as a supervisor. And also, a supervisor can supervise as many teams as they want to. Okay, so this is what happens during and after the competition. So during the entire contest period, which is about 10 days, this year I think it's like 9 days, the supervisor has access to the problems. So typically they have access to these problems from the website, and they just give the team these problems when it's time for the team's testing period. Oh wait, sorry, I forgot. So the middle school testing period is 60 minutes given for 20 problems, and the high school testing period is 90 minutes for 30 problems. So during their testing period, at the start of the testing period, the supervisor will show the team their problems, and the team clock on the website will oh, record their time. So during the competition, the team will fill out their answers on the website, and then they will submit it before the team clock ends. And a few days after the competition ends, the results are posted on the Purple Comet website. So uh, there are several kinds of results that they post. They first post overall results for each of the 8 types of teams. Then they post results by country and by state if the team is in the US. Also, for the supervisor giving the problems, the supervisor can like print out copies of the problems before the team starts their testing and distribute these printed copies when the team starts. Okay, so now we'll just be moving on to some problems. And keep in mind that all these past problems and answers and some solutions are on the old contest page of the website here. Okay, so our first problem is from the 2023 middle school contest, and it's number 19 on the contest. So a trapezoid has side lengths 24, 25, 26, and 27 in some order, and we want to find its area. So the main part of this problem that we need to deal with is this, in some order. In some order. So we don't know which order the sides could be in. So the first thing that we should do when approaching this problem is we should do casework on the bases. So, for example, one possible trapezoid we could have is this. And the bases are used to determine the area, so it's important that we do casework on these. So, for example, let's just see what happens when we try to find the area of this trapezoid. We just drop a height height h, because we need the bases and a height to find the area of a trapezoid, and we can use the Pythagorean theorem to try to find h. So since this middle section is 24 of this base, these two sections add up to 2, so we can just let this be x and 2 minus x. Okay, so the Pythagorean theorem just gives us 2 equations. Okay, so to solve this equation, it's I would just subtract these 2 equations, so we can eliminate the h, and we get something like this. So this is just a quadratic equation in one variable. So it turns out that if you solve this, you actually get the solution x equals -25 and h equals 0. But this is not good, because this means that a trapezoid just looks like this. A trapezoid is just a line. So the way that one could proceed doing this problem is just like testing out every case of like the orderings of these 4. But one thing that you can notice, I think this is pretty hard to notice, but is that 24 plus 27 equals 25 plus 26. And this like kind of motivates one to conjecture that like if you have a trapezoid, let's just say ABCD, with this side length A, B, C, D in that order, and you have A plus B equals C plus D, then that trapezoid is a line. So I think that this kind of becomes clear after you test like a lot of these cases. So the problem is possible through just testing every case with the Pythagorean theorem and finding that Like most of them are lines, except for one specific case, but I think this is pretty nice to notice. So this is verifiable by the Pythagorean theorem, but I want to offer an alternative proof. So let's just assume without loss of generality that A and C are the bases, otherwise we can just like relabel them, and C is greater than A. So notice that we can just kind of like cut out this rectangle. That leaves us with a triangle with side lengths D, C minus A, B. Also notice that if this triangle is a line, then the entire trapezoid was a line, because then this would be like 0 degrees, this would be 0 degrees, and then that would just make this whole thing a line. So notice that we can rearrange this to, we can rearrange this to D plus C minus A equals E. However, by the triangle inequality, that just means that this triangle is a line. So this is the reason why this holds for trapezoid and this labeling, then it's a line. So now we just want to find some ordering of these numbers as sides of the trapezoid such that like these two sides don't add to these two sides. So it turns out that like if we have 24 and 27 here in some order, then these will have to be 25 and 26 in some order, and then that's bad. Similarly, if we have like 24 and 27 here. So it turns out that these are the two cases that we're left with. We need 24 and 27 opposite of each other, and 25 and 26 opposite of each other. Okay, so now we could either go by the Pythagorean theorem, like hx, h 3 minus x, since these two add up to 3, sorry. Or we could like do this. We could just cut out this rectangle again, 25, 26, 3. Sorry that this isn't to scale. We could use like either this, or we could use Heron's formula to find that, and then add back this rectangle. But let's just use the Pythagorean theorem. So doing this, because these two add up to 1. So the bottom case gives us h squared plus x squared equals 27 squared. H squared plus 1 minus x squared equals 24 squared. Okay, so this case is also kind of bad, because if we solve this using like the method of just like subtracting these two equations, getting rid of the h, and plugging it back in, we actually get that h is an imaginary number, and that is not possible. So this is the only case we have left. So that just gives us h squared plus x squared equals 25 squared. H squared plus 3 minus x squared equals 26 squared. So if we just solve this equation, that'll give us x equals -7 and h equals 24. So that gives us our h. And this may seem invalid, but it actually leads to a valid trapezoid. So when I solved this problem 2 years ago in the 2023 middle school contest, I was very confused when I saw this. So I'll just show the interpretation of this condition. So let's just say we have 2 points, x and y. Okay, so this is 7, then like this xz could be -7. So applied to the trapezoid, that makes it like this. Let's see. This equals 10. This is the -7. So yeah, now we have our trapezoid. So now we just use the formula for the area of a trapezoid, and we get that its area is 24 times this, which gives us 612. That's our answer. Next problem is from last year's high school contest, so number 20. This is an algebra problem. So we let a, b, and c be real numbers such that a plus b plus c equals 3 root 3, and a cubed plus b cubed plus c cubed is 11 root 3. We want to find this. Okay, so these can be recognized as symmetric polynomials. So in fact, everything here is a symmetric polynomial. So when presented with symmetric polynomials, we can often like get around to other symmetric polynomials. In this case, one identity that we want to use, a symmetric identity, is this. This is a pretty common thing. For any real numbers a, b, c, we have this. So yeah, we already have most things that we want. So we have this, which we know, with this, which we want, this, which we want, we have this, which we know. So the only thing that we have to deal with is this, except for we can recognize that this is like almost this. It's almost a plus b plus c squared. So we can actually rewrite this as a plus b plus c, and then a plus b plus c squared minus 3 this. So now we pretty much have everything we want. We have this, and this. So now all that's left to do is just plug in some numbers. So plugging in everything gives us 11 root 3 minus 3 ABC equals 3 root 3, 27 minus 3 is. All right, so actually expanding this will give us oh, 9 root 3, sorry. And then if we just move around some terms and divide by root 3, we'll get that this is equal to 70. So that's the answer to this problem. Oh. Okay, so now for our third sample problem, we have a counting problem that's from last year's high school contest. It's number 29, so that's like the second last problem on the high school contest. So it's pretty hard. So we have Erica and Alan who each flip a fair coin 5 times. And given that Erica has flipped more heads than Alan after each has flipped the coin 2 times. We want to find the probability that Erica has flipped more heads than Alan after each has flipped the coin 5 times. So this, we're given something, we want to find a probability, so we can recognize this as conditional probability. So if we just let this be event A, that Erica has flipped more heads than Alan after 2 coins, this be event B, that she's flipped more than him after 5 coins, then we really want to find this. This is the formula for conditional probability. So I think Purple Comet problems, counting problems at least, are usually pretty casework based, and they really rely on choosing good cases. So in this problem, we'll break it down on like how many heads Erica is ahead after flipping the coin 2 times. Because so there are only a few choices of cases that we can do. It's pretty evident that we have to use casework because like not a lot of other, well, flipping a coin, this is kind of just like casework-ish. So we could, the other cases that we can choose, I guess, could be like what the number of heads flipped is, so like 2 0, 2 1, or like 1 0. But this case, that case still works, but just doing cases on the number, how much Erica is ahead, is just faster. So we can letting E be Erica's flips, Erica's heads, and A be Alan's heads. We can divide this into 2 cases. We can Erica has 2 more flips, 2 more heads, or Erica has 1 more head. So we'll just have the first case here. So we want the probability of this case happening first. So it has to be 2 0, Erica's heads to Alan's heads, and this is just 1/4. Probability of this occurring is 1/4 times 1/4 equals 1/16. Okay, so oh, sorry. First I'll write out like the probability of something is occurring. So we want the probability that someone flips 0, 1, 2 heads out of 2 flips, 0, 1, 2, 3 heads out of 3 flips, because this will aid us in finding these probabilities. So this would just be 2 choose 0 over 2 squared, which is 1/4. 2 choose 1 over 2 squared, which is 2/4. And 2 choose 2 over 2 squared, which is 1/4. This we have 3 choose 0 over 2 cubed, which is 1/8. 3 choose 1 over 2 cubed, which is 3/8. 3 choose 2 over 2 cubed, which is 3/8. And 3 choose 3 out of 2 cubed, which is 1/8. So that's where we got this 1/4 and 1/4 from. So in order for this case to work, we must have Alan on the next 3 flips. See, next 3 flips to get to 5 flips gets less than E plus 2. Because if Alan gets at least Erica's heads plus 2, then he'll be even with Erica, or he'll have flipped more heads than Erica, which is not what we want. So we want to find the probability of this. We're actually going to use complementary counting for this. So we're going to do like 1 minus the probability that A is greater than or equal to this, because there are less cases. So complementary counting is not necessary for this, but it's just faster than counting it the regular way. So we could either have Alan gets 3, Erica gets 1. Alan gets 3, Erica gets 0. Or Alan gets 2 and Erica gets 0. So if we just plug in some numbers here, we get, this is 1/8. This is 1/64. Oh wait, no, sorry. This has a 3/64th chance of happening because it's 3/8 times 1/8. 1/64th because it's 1/8 times 1/8. And 3/64ths because it's 3/8 times 1/8. So this has a 7/64 chance of happening. But since this is what we don't want, we need to subtract this from 1. So this has 57/64 chance for the first case. Okay, so now so far we have uh, this. This is the first case for this event that she's flipped more than Alan after 5 times. And this is the first case for this event that she's flipped more than Alan after 2 times. So now we move on to the second case. Okay, so yeah, E equals A plus 1. So we could either have Erica has 2, Alan has 1, or Erica has 1 and Alan has 0. So each of these has probability 1/4 of occurring. Oh wait, no, 1/8 of occurring, sorry. So the total is 1/4. So now, similarly to last time, we need this to happen. We need this to happen, or else Alan will have greater than or equal to heads when compared to Erica at the end, which is what we don't want. And again, we'll use complementary probability to count this. Okay, so for this to happen, we could either have Alan gets 3, Erica gets 0, Alan gets 3, Erica gets 1, Alan gets 3, Erica gets 2, Alan gets 2, Erica gets 1, Alan gets 2, Erica gets 0, or Alan gets 1, Erica gets 0. So we just compute these probabilities. 1/64th, 3/64ths. Sorry. Just write the probabilities here. We got 1/64th plus 3/64ths plus 3/64ths plus 9/64ths. I'm going in order like this, this. Plus 3/64ths plus 3/64ths. And this is a total of 22/64. However, we want 1 minus this because we just counted the cases that don't work. So we have 42/64 for this case working. And we're leaving it unsimplified for now so that it's just like easier to compute here. So again, for conditional probability, we want the probability of both events occurring over the probability of the first event occurring. This is just our cases. So this is like the probability that the first thing occurs. This is our cases. This is the probability that the second case occurs for the first in total, basically, because we have 2 cases and we sum them all. So if you just calculate this, it will give you 225 over 320, which is equal to 45 over 64. And our answer is 109. Okay, so I just want to give some brief remarks on like the style of Purple Comet. Okay, so I think that like Purple Comet has a pretty unique problem style. So uh, I think that like the geometry and number theory are usually like pretty nice, nicer than the AMC, their corresponding AMC AME problems. Like for example, on this geometry problem, we had like the insight that like you can remove this rectangle from a trapezoid. Uh, yeah, so I think that the geometry and number theory are pretty nice. I think that the algebras are pretty standard, like kind of like just like AMC or Amy problems. Sometimes there's a trick like the identity that we used here, the A cubed plus B cubed plus C cubed minus 3ABC. But like here, it's like important to know symmetric polynomials here because that kind of motivates a person to use that identity. I think that the counting problems are usually pretty casework oriented, although they like really rely on choosing good cases like we just did. And some are still like pretty insight based, like requiring something like this though. So some more of my opinion on these problems is that like I think the middle school contest's difficulty is like ranging from I'd say early AMC 10 to like early to mid Amy. So this is like one of the last problems on the middle school contest from 2023. I'd say that this is like around early to mid Amy. And I'd say that the high school contest difficulty usually ranges from like early to mid AMC 10 to problems like this, like late Amy, and sometimes beyond late Amy. But keep in mind that this is just my impression of the problems. I think that these three sample problems pretty well show the style of Purple Comet, like this geometry, algebra, and counting. Okay, so now we have a Q&A. Does that anyone have questions about either the problems or the rules?
Hi. I think you mentioned in the beginning, every student can attend up to two exam. So can you explain that?
Oh, okay. So this is who can be in a team. So yeah, a middle school student can both be part of a middle school team and a high school team if they want to. Uh, but no student may be in two middle school teams or two high school teams.
Thank you. If I cannot find any team member local, is it possible for me to find someone online to take the test?
Oh wait, okay, yeah, I think so. So the official rule is uh that the contest cannot be taken the contest can be taken in different locations. It just needs to like everything needs to be supervised by by the team supervisor, and that would be like mixed teams. So mixed teams, although it can be taken online, uh, I think the team members still need to be live within 150 miles of each other. But I think like exceptions can be made by reaching out to Purple Comet. Okay, anyone have any more questions about this?
Do you have any advice to the middle school student? How can they prepare for the competition?
I think like just looking over some of the past problems here is will be sufficient because I think Purple Comet is pretty consistent with its problem style over the years, although like I think every year's problems are kind of unique. But I think like this is like the best way that you can find Purple Comet's style. Like I guess look at some so like yeah. Here you have high school problems, middle school problems, high school answers, and middle school answers. These are all on the website. So like I think like most of these meets probably up to like early 2010s will all be like pretty consistent in style with like the current meets. And again, oh wait, I think the last 2 years also might have solutions, not just answers. And okay, I think that well, I think that like doing these problems is pretty good preparation. And keep in mind that like the registration for this year's contest is still open, like all the way up until late April to early May.
If I only have like less students in the team, for example, two students in the team, will that affect the final results compared to a team
Uh,
with six
no,
person?
that will not affect that. Oh, it's still allowed for a team to have two students. Like a team can have anywhere from 1 to 6 students. Like even one student is okay. That'll just like affect uh like a team with two students might not be able to complete like every all 30 problems of the high school contest or all 20 problems of a middle school contest, but they'll still be like ranked the same in like the results. It'll just be more difficult to do well on the contest.
Thank you. So can you share some experience when you do the middle school competition? Do you have a strategy like how to arrange which person doing which problem?
Yeah. Uh, so yeah, there is some strategy to doing this. Like I suggest taking the contest in person rather than online because like in person also gives the team like a chance to like work together and like practice on past exams, and I think it allows for like division of the problems easier. So yeah, I'd suggest like with a team of like 5 or 6 people, then to like assign problems to each person or sometimes like collaborate on problems and like exchange ideas on like some of the more difficult problems. So I think like maybe dividing like around the first 18 for a team of 6 or like 15 for a team of 5 into like assigning some problems for each person like that and then like working together on the later problems is a pretty good strategy for this contest.
So will you have enough time to cross-validation each other's
Yeah,
problems?
I think it's all, yeah. So 60 minutes for 6 people to do 20 problems and 90 minutes for 6 people to do 30 problems. So I think like that's like a lot of time given like the amount of people that can be on a team. So I think like yeah, checking problems with each other is also a good idea because that's like I think like that's like helpful, really helpful to make sure that every problem gets like answered correctly with a team of like 5 or 6 people.
Do you have some recommendation on how a middle school student can start learn math?
Uh, yeah, so okay. That would mainly be things like LPS. So I think ALPS is a really good resource for this. So like there are a lot of things on ALPS. See, there's like a lot of training material. So this is training. And then I think like on the forums, there's usually like a lot of people talking about these competitions and problems as well. I think that LPS is a really good resource as long no, as well as also like just looking at past problems. Like LPS has a lot of past problems. So uh they have a lot of like AMC 10, AMC 8 problems. I think those are pretty good for practice. And then there's also AOPS contest collections, which has like a ton of these are like harder Olympiads, but also like see USA contests. Uh, and then there are like contests like this and yearly contests. So see here in USA contests, we can find like AMC 8, AMC 10, all these. We can also some like college hosted events. And okay, so these are like going to be discussed later. Some of these are going to be discussed later in the larger STEM math talks and see some middle school tournaments. I think that these are pretty helpful, just like looking through some of these problems. So like, uh, say like clicking on this, we can find like a bunch of problems. See, I think that like these are all middle school level and they're like pretty helpful for learning. Uh, I think like there are also a lot of handouts on the LPS forums, so I think like they're not that common, but like handout if there are handouts, they're usually like all pretty helpful. Uh, yeah. Oh, I'd also recommend probably Math Dash, which has like a lot of training resources as well.
Is the purple comet only for middle school and high schoolers?
Wait, I'll just finish talking about this and then I'll address that. So yeah, Math Dash has a lot of resources as well. So like there's like training. I think there's like a lot of handouts. There are a lot of handouts and like practice competitions to do on Math Dash. So I think that this is a pretty good resource as well. Okay, so back to that question. No, it is not only middle and high schoolers that can compete. So, yeah, on non-competitive teams for middle school and high school, anyone can participate in a non-competitive team, regardless of their grade or age. So you could have like a high schooler, or like you could be like a college student, I guess, and take these competitions. It's just that you can't be in one of these competitive teams, small, large, or mixed team, if you don't meet the age and grade limits.
Okay.
So can the is there any competition that elementary school student can take?
Yeah, so the Gauss Math Tournament, of course, is a really good competition for elementary schoolers. It has like one division for elementary schoolers. Oh, two, I think. And I think that's pretty good for also pretty good preparation for future contests like Purple Comet and like that the other ones that we'll talk about in this uh, contest series. So Gauss Math Tournament is just like right here. Tournament. So, oh, this is the 2024 one, but the 2025 one will be available soon, I think. It'll take place in June, I think. Uh, yeah, so I think there are also some elementary school competitions that are available on ALPS. So yeah, there's a list. There's actually like a lot of things on ALPS. So like a lot of these lists and a lot of like topics. So for example, so yeah, like intermediate math competitions and topics. I think like these can be also useful for studying for contests, especially to middle schoolers. I think like uh, these will really be useful for like starting math. So yeah, here are a lot. And then there's some by state. Yeah, so I think like along with these, Gauss Math Tournament is pretty good. So yeah, here. And then there are a lot of problems on here as well. So like if you wanted to find some counting problems to do at the intermediate level, then you could just like go here. Okay. Okay, I think I forgot to mention something earlier for this slide. It's not that important, but okay, so like schools can spend uh school teams like small and large, they can schools can send as many school teams as they want to take this competition. So like yeah, a school can have like as many like teams of its size as it wants. And like supervisor can be like a math teacher or anyone like that. Okay, so if no one has any more questions, I guess yeah, this is the end of the Purple Comet talk. So Yeah, thanks for listening, everyone, and have a good evening.